Saxon Algebra 1/2, lesson 94. Today we are going to talk, my students, about adding like terms. Here's an example. Let's say that we have 3 oranges. I'm talking about the kind of oranges that you eat, okay? You could write this collection of things as 3 oranges. You're adding them up, right? You're looking through your fruit bowl and you're adding things up. Now let's say that you also notice that you have 2 apples in your fruit bowl, which we can write like this, 2 apples. And if someone were asking you to give like an inventory of your fruit bowl, that's probably what we would tell them. We have 3 oranges and 2 apples. Your mom's getting ready to go to the grocery store and she's making a list and she's wondering how much fruit to get. So you tell her that you have 3 oranges and 2 apples. You would not say we have 5 apples, because you can't combine apples and oranges. They're 2 separate things, and so you need to count those separately, and you wouldn't add them together because you'd be mixing, as the expression goes, apples and oranges, and you just can't do that. It doesn't make sense to do it that way. Now, this is the way it works in real life, but we have a very similar thing that happens in algebra. Sometimes we're counting one variable, and we wouldn't call it oranges necessarily, but we might call it x. And we could add those up just like we added up our oranges, and we would say we have 3 x's. Makes sense, right? And then our apples, we might use a different letter. X is the first choice that mathematicians usually make for what we call a variable. X is a variable. Whoops. Y is a variable. Okay? Because depending on what we want to plug in, we'll get different answers. And we would say that we have 2 y's. And just like we wouldn't add the oranges and the apples together because they're different, we don't add unmatching variables together. An x and a y are 2 different things, and we don't add them together. However, we can add together anything that's an x, and we can add together anything that's a y. So that's the basic rule for adding like terms. We say they're like terms if they match. These are like terms. These are like terms. These are not like terms. Now, a term can have 2 parts to it. And I'm going to give that just as an example. This part is called the constant because the 7 is a 7 and it doesn't change. And this part is called the variable because, as you know, we can choose different values for x and we can plug them in, and that will change what the value of this overall expression is, right? If I tell you x is 1, that's one thing. If I tell you x is 500, then this represents something very different. Okay, now here's the last thing about variables before we begin the example. If the variables match, then we say that the expressions are like terms. And we can add them. Okay, that's our rule that we're going to go forward with. If the variables do not match, then we literally have apples and oranges and we just have to leave it, right? Okay. Example 94.1. Simplify by adding like terms. The worst thing about these problems is writing them down because they're long. Okay? This is a constant. This is a constant. This is also sometimes called a coefficient because it's a constant in front of a variable. So that's kind of like its special Hollywood glamour name. Okay, so what we do with a problem like this is we look through for matching variables, right? If the variables match. So what I like to do, it's nice to use other colors, but if you're too lazy to just pick up and put down different colored markers, this is what I do. Okay, I'm gonna underline the X's. There's two X's. Now I'm gonna combine their coefficients, the constant number in front of them. Just like when we're adding up the oranges in the fruit bowl, we add them up, right? 1, 2, 3. Minus 3 plus 2 is minus 1x. When we're writing minus 1, we can leave out the numeral 1, but I'm going to leave it there just for now. Now we're looking for the y terms. There's just one, so we'll do that. And then we've got two constants, so that we add them together to get 10. All right, so we're adding like terms. We're adding things where the variables match or there's no variable at all. Okay, does that make sense? We can also rewrite this as John does. We can just drop that y out of there. Minus x plus 2y plus 10. This is the way John shows the answer. If you showed me this on a test, you would get full credit. That's fine. All right, and then the second example for lesson 94. 3x plus 2m minus 14x plus 2x Okay, you keep copying and I will double check. Make sure I got it right. Okay, this time I'm going to use different colors and show you how we can use that. Here I use the same color, but you'll notice I just made different kinds of marks, right? Straight lines, straight single line, squiggle line, double line. You can circle them, but do something with your pen to mark each different kind of variable so that it will be clear to you which ones you're combining. Okay, I'm going to use different colors this time. This is really ideal to just underline all the matching terms. Okay, and sometimes it's even fun to do this. All right, 3x minus 14x plus 2. I'm going to add together the two positives. That's 5. And you can write it down if you want. Plus 5x minus 14x. That gives me minus 9x with my orange. Next, I will go to green, and I'll do the m's, that variable, in green. Notice that the sign goes with it. It's a package of sign, number, and variable. Okay, plus 2m minus 4m. I'll just jot it down here so you know what I'm doing. That would be minus 2m, right? Because we're down 4 steps, we're up 2 steps and then we go down 4, that would take us to minus 4. And then my constants here, we can combine them. Plus 4 minus 2 is plus 2. So there is my final answer. Let me double check with John, make sure I didn't go insane, which I do from time to time. Both of these are right. Okay, so number 1, some students are tempted to not copy down the problems because it's kind of a pain and they want to just look at the book and do it in their head. You can try that if you're really strong at mental math. You can practice just doing it in your head. If you are successfully getting right answer after right answer, then that's fine and you can do it in your head for a while. I promise you that it is going to get harder and eventually you won't be able to carry it in your head. But for now, that's fine if you want to do that. If you don't like to carry numbers in your head, you prefer to see it written down like me, I'm super visual, write it down. That's no big deal. Here's the advantage to writing it down. If you're showing me your work like this, underlining and circling and showing me how you're combining things, I'm much more likely to be able to give you partial credit on a question that you don't get completely right, but partially right. And you can be sure there'll be problems like this on the test. If you're doing it in your head and just writing down the answer, I can't see what you're doing. So I can't give you partial credit on that. And if you can live with that, I can live with that. I'm going to really let it be your call in the early stages of these problems because they are somewhat easy to do in your head. Later, we'll get to a point where I'm going to tell you, no, write it down. You have to write it down now. It's too much to try and do in your head. Okay, I've walked this path with students for a long time, and I know there's a tipping point at which you can no longer shove all the information in your head. But for now, that is called adding like terms. We're going to be doing it forever, so it's really useful and important. And I believe in the next lesson or two, we're going to make it a weensy bit harder. But for now, that's adding like terms. Yay. Thank you. Goodbye.